This is Deepak Chopra again, and we are continuing our conversations with luminaries in science, philosophy, the arts, uh, conversations that expand our mind, our awareness, and give us an opportunity to question our habitual certainties. I'm certainly guilty of that. I've been guilty of habitual certainty all my life. So I start with that confession. We are here principally to have a conversation with three influencers in the world of science and physics. First, Frank Wilczek, who's a Nobel Laureate. You'll see all his credentials and you'll see a link to his book, which is absolutely fascinating. We have Brian Keating, who's also a cosmologist, very involved in the original experiments looking for gravitational waves. And we have my friend Leonard Mlodinow, who I met at Caltech on a debate with skeptics like Michael Shermer and others, but we ended up being amazing friends. And Leonard has written 2 books with Stephen Hawking and has also co-written a book with me talking about the different perspectives regarding science and what we call spirituality. But spirituality is a loaded word, and we have to be careful how we use that word, and we'll come to it in a moment. But this conversation that we're having was initiated by Brian Keating. Brian is a very significant cosmologist, physicist. I've known him for a while. I think we met together here at some of the conferences in San Diego with Roger Penrose and other people. So, Brian, you initiated this. Tell us why.
Well, thank you so much, Deepak. It's good to see my friends all gathered around. We won't team up on you, Deepak. Don't worry. It's not going to be a physics intervention where we try to convert you to become a physicist like us. But in reality, I feel like the environment that we're in now is a very dangerous one for society as science loses some of its, prestige perhaps, or we believe that debate is impossible in the political sphere, and that seeps into the scientific sphere, making it impossible for people, perhaps people of faith, perhaps not, to debate scientific and philosophical questions with comity, with friendship. This is what I wanted to arrange, because I think there's really no better interlocutor than you, Deepak, to take these different worldviews, as you and Leonard are fond of saying, and try to find some comity between them, not for the sake of consilience, just so for its own sake, but for actually doing good for the world around us. And I felt like these gentlemen, Frank and Leonard, are 2 eminent scientists that I look up to and have learned a lot from. And also, I'm not afraid to debate with me as long as it's done civilly. And I think that's my goal.
Brian, we need to come to your book as well, Lucy, the Nobel Prize, because we have a winner of the Nobel Prize.
That's right. No, we talked about that when Frank was on my podcast, the Into the Impossible podcast, which I run from the Arthur C. Clarke Center.
We can come to that, but let's start with Dr. Wilczek. Frank, may I call you Frank, sir?
Yes, of course. Yes.
So Frank, a while back, Science magazine published the 125 open questions in science. And the first one was, what is the universe made of? And the second one was, what's the biological basis of consciousness? And I stopped right there because, the rest of the questions, I think, depend on the first 2 questions. What's the universe made of? And what's the biological basis of consciousness? Or is there a biological basis of consciousness? And so I was fascinated by your book, which is called Fundamentals. And it's an extraordinary book. I spent the weekend reading it very carefully. And I learned a lot. There was a lot that I knew thanks to Leonard, and Leonard and I have had a good relationship over many years. So there was a lot there that I did understand. There's a lot there that I did not understand. But here's the question that I have for you. right off the bat, and it's your question in a way, what do we know of the physical world? What is the world made of? Because my understanding is only, that there might be 2 trillion galaxies out there. 2 trillion. There
Yes.
might be 700 sextillion stars out there. There might be uncountable trillions of planets out there. And that may be less than 1% of the visible universe. So what's the universe made of?
Well, at a fundamental level, the universe is made out of space, time, and quantum fields. And that is a very rich structure from which you can make a lot of things, the sort of things you mentioned. But fundamentally, there are very few concepts that we can boil down the description of the world to, and that's an extraordinary statement and an extraordinary achievement.
I read that the world is made of space, time, and matter, but you also said fields, and then you said dynamic complexity. What do you mean by dynamic complexity?
From these ingredients, you can make dynamic complexity, which is a way of representing and processing information. So those are emergent concepts that just as from Lego bricks, you can make extraordinary structures. And if you supply them with motors, you can make even more extraordinary factories. From a few ingredients put together that have the right properties, fortunately, you can make stable but not too stable arrangements of matter that allow us to have patterns that can be interpreted as patterns of information, and that have a useful stability and a useful regularity that support different kinds of objects that you mentioned, stars, planets, but also humans, individuals, animals, and so forth.
So if the world is made of force fields, particles, wavicles, as some people call them, why does it look like this? Why does it look like you, me, and everything else that we're looking at right now?
Well, that's a tough job that we have as physicists, to show how from these very abstract concepts that we've boiled it down to, that you can reconstruct the world. It's been a remarkable journey from Democritus, who talked about atoms in the void as opposed to warm, cold, the taste of different kinds. He had the vision that actually the fundamental part, the description of the world, was something quite different. And ever since, we've been learning that lesson deeper and deeper. We've been trying to get a more and more compact description, and now we have, for practical purposes, I believe, a complete description of how matter works. And you could put it all into a computer program and teach it to a computer, and the program would be shorter than, say, the program, and less complicated than, say, the program for Word, because the basic principles are very, very simple. However, in that profound sense, in that very precise and profound sense, you could teach it to a computer without loss. However, the world is so abundant in terms of how many copies of these structures it has and supports, and these structures are so rich in the ways they can combine and function with each other, that we don't see any barrier to making the world we see around us out of those ingredients. And you don't have to take my word for it. We're speaking at the moment from at great distance over computers made of transistors that were designed using quantum mechanical principles, and the information is carried by waves that propagate through space according to Maxwell's equations. It really works. And we've in fundamental physics, we've been on a journey now for close to 600 years to boil down to description shorter and shorter. That's what we try to do. We do analysis to get the most basic equations and then synthesis to build things back up. And both of those directions are important directions for science. And we've done, I think, in culminating in the 20th century, the late 20th century, we've done an extraordinary job of analysis. And now our big challenge is mainly synthesis. There are loose ends in the description, to put it mildly, of fundamentals. I think you've alluded to the fact that if you consider the universe by mass, the kind of matter that we really understand deeply is only about 5% of the mass of the universe. And there are other ingredients called dark matter and dark energy, about which we know a few scattered facts, but we don't have a really precise description worthy of standing beside our description of other elements of matter and the universe, of those things.
And the 5% that you referred to, most of it, 99.9% of it, is invisible interstellar dust, mostly hydrogen and helium. So the actual visible universe is even less.
There are two kinds of dark matter. There's dark matter made out of the stuff we know about, which is not so mysterious. And that's, as you said, distributed in gas clouds and things that are just hard, but hard to detect. But modern astronomy is pretty good at seeing signals from those things. And then there's some other component that's about 6 times as much. So the kind of matter we understand really deeply, that's the subject of biology and chemistry and all forms of engineering, made out of quarks, gluons, photons, and electrons we understand deeply. That's about 5% of the universe by mass. And then there's something called dark matter that we're not sure what it is. I think I know, but the evidence is not really fully in place. That makes up about 30% of the universe by mass. And then there's something called dark energy, which is still quite mysterious, but we know the equations it satisfies, but we really don't have an intimate knowledge or even an intimate guess of what it's made out of.
So Dr. Wilczek, you said something very interesting right now. We know that this works. We are having this conversation.
Yes.
You and I are speaking. Millions of people might be watching us. Ultimately,
Yes.
we hope to reach 15 million. Let's have your book a little more prominently displayed. You can look at it. The 10 Keys to Reality. So Leonard and I were once speaking in Sweden at the same place where you got your Nobel Prize. Mm-hmm. And I mentioned that science is very effective, but is it getting us closer to truth? And there was somebody right in the front seat who said, Dr. Chopra, how did you get here? I said, I took a plane. He says, you trust your life with science, and yet you say, is it getting us closer to truth? And, you know, he got a standing ovation just for his remark. So, you know, this brings me to my second question, which is something that Leonard and I talk about a lot. Can mind emerge from matter? And so I'd like both your opinion on that, Leonard's opinion, and Brian's opinion on that.
I think certainly certain kinds of mind can emerge from matter. We know that. My computer will beat me at chess sometimes, and the best computers will beat the best humans at chess or Go, or many things that were thought to be fundamental indications of mind and intelligence. Now we know can emerge from matter because we designed them that way. And the domain of things that our machines can do is expanding very rapidly, exponentially as we speak. And the artificial intelligence is catching up with natural intelligence on many fronts. And there's no question that that's emerged from matter, because we know exactly how it works. We designed it from the ground up using quantum mechanics. And now there's another question, which is whether the minds that humans have, that we sort of experience by introspection and by interaction with other humans, whether those are really emergent properties of matter. And there we don't have a complete understanding by any means, but I think the program that dominates neurophysiology is to assume, yes, that it does. And so far, there haven't been any showstoppers. After, with years of more and more detailed investigations of how memories are stored, how memories are laid down, how the different electrical signals within and chemical signals within the brain and the rest of the nervous system are propagated, how simple nervous systems in simpler animals work. That there we can understand almost at the molecular level. So all those indicate that the substrate, the material substrate of mind is matter as we know it, and that this doesn't detract from mind, it enhances what matter can do. We understand its potentials much better. And one more thing I would add about that is when physicists do experiments, they have to be very careful now with modern delicate experiments that measure, say, the position of mirrors to within, in the case of the LIGO gravitational wave detector, to within 1/10,000th of the diameter of an atomic nucleus. And we do many other extraordinary things like measure time with an accuracy of 1 second per lifetime of the universe with atomic clocks, and compare them. And so people have to make all kinds of corrections and precautions for temperature, for vibration isolation, for getting a very good vacuum, for making sure that the things are very cold so that they're not thermally excited. But one thing that people have never had to correct for is what people in the lab next door are thinking. There's never been any demonstration in these very precise, delicate experiments of any ability of mind to control matter. So that's a very powerful constraint to me on the idea that there's something other than a property of matter involved in the phenomena we call mind.
Okay, so, for the last 4 years, I've been engaged in creating AI version of myself. And it's going to be released in 3 weeks. It's called Digital Deepak.
All right.
So we had a demonstration of it with Wall Street Journal. And the journalist asked my AI version, what did you eat for breakfast? And he said, I don't eat breakfast. And
Yes.
I don't eat breakfast. I don't feel hunger. I don't have sexual urges. I don't fear death. So I'm talking about that kind of mind, that has subjectivity imbued in it, longings, aspiration, creativity, vision, insight, inspiration, intuition, reflection, contemplation, meditation, all the things that you talk about in your book.
Yes.
And I don't see how mind, or, I also have a practice at night where I do a meditation where I recapitulate my life. I look at myself as a boy, as a child, as a teenager. I can't identify with those people. They're like ephemeral memories that come and go. And I have a very hard time convincing myself that my self-reflection is the interaction of force fields and gravity and wavicles and particles. I want to be convinced of that. But I keep asking myself, who is having these experiences? What is questioning this? And can a machine or matter ever experience subjectivity? Now, of course, my body is made of matter.
Yes.
And I'm experiencing it, but who's the I that experiences what I call my body? That's a different question. We might come to that in the end, but I want to go to Leonard right now because what you raised is very...
the only thing I would say in response is don't underestimate matter.
Yes, I would also say...
We know that matter can do some very surprising things.
Yeah, I want to come to that because, I also want to quote from your book, which says something very interesting.
Yeah.
We are big enough specifically to contain the entire universe in our minds. And
Yes.
elsewhere you say, I'm large, I contain multitudes. And
Yes, that's Walt Whitman.
Walt Whitman, who is a
Yes.
favorite author of mine. I was also thinking of Rumi, the Sufi poet, who says, look at your eyes, they're so small and they see enormous things.
Yes.
Rumi also says, I'm so small, how can the whole universe be in me? So I want to go to Leonard right now because, he was so close to Stephen Hawking, who was physically quite handicapped. And yet his mind explored the far reaches of the universe, going all the way to singularities and black holes and Hawking radiation and all that. So, Leonard, please comment on what Dr. Wilczek has just said. Can matter create mind? What's your opinion?
I agree with Frank, and I think he said it quite well. And there's never been any evidence in all the history of science of any effect or forces of the mind that are not attributable to physical forces. And I think that as a scientist, hopefully we are all open-minded enough that if some evidence would come up, that we would investigate that and theorize about it and accept it. But in the absence of that, even though there are many mysteries in the universe, there's mysteries of what is dark energy, there's mysteries of who am I, as you say, right? And who's experiencing this phone call, and who likes you, Deepak? Who loves you? Where does that come from? I don't know, but because I don't know, doesn't mean that I, attribute it to something beyond what I've so far observed. I just don't understand how it is. And I would like to make one other point that came to me as you were talking and Frank was talking, which is my friend Christoph Koch, who I used to know very well back at Caltech. He does neuroscience research into consciousness, as you know. I know you know him. And he told me long ago when I was thinking of writing my book Subliminal on the unconscious mind, that when a scientist studies the unconscious, it's much different than when people, philosophers or people outside of science study the unconscious, because we have to operationalize it and we have to study very specific, concrete, well-defined questions. So when he studies the unconscious, he studies the visual system of the brain and how your brain, through different layers, processes information. As you know very well, Deepak, the photon, the data, the optical data that hits your retina is not what you experience. And it goes through many different layers of processing, and your brain is really constructing reality, your experience of reality from that data, but it's not an accurate reflection of that data. That's why we have, for example, optical illusions and things like that. And so when a scientist studies consciousness, there are scientists who are interested in it. We're not, it's, decades ago, it was considered a taboo subject. I think kind of crackpots would study it, but now I think it's taken seriously. But we do it very slowly, step by step, by understanding how the neurons in the brain work, how different, very specific phenomena in the brain occur. And we try to get at it piece by piece, step by step, and probably it's going to take another, decades and centuries perhaps before we understand it. But that's our approach. And when something's a mystery, we approach it, but we do it step by step in a very methodical, reductionist manner. I know we don't like that word. Not that we don't look for emergence, because I don't like the word reductionist, but we looked at it, I would like to say, in a systematic and very well-defined manner, using methods that we know make it harder for us to be fooled than if we just the ordinary person contemplating.
That's great, Leonard, and we've discussed this before, and many times. Brian, any comments on what has been said so far? I should mention, we are talking about Dr. Wilczek's book, Fundamentals, 10 Keys to Reality. Please look it up. We'll have a link to that, to Amazon and other sites. A link to Leonard's book, which is a memoir of his relationship with Stephen Hawking, and a link to Brian Keating's book on why he didn't get the Nobel Prize.
I did get it. Frank left his when he came to visit me. So
okay.
No,
Brian, what do you say to this comment so far? Because I want to move on to something.
Yeah, the only thing I want to add is
Wilczek's comments. Okay.
Yeah, I had a little bit of a taste of that conversation with Frank, and I also talked with Noam Chomsky over the summer. I've got finger puppets of all my guests, so we're working on one of Leonard, and Frank's on the way. But the thing that concerns me after talking to so many people in the last year, eminent scientists and thought leaders, so to speak, is that we seem to be really obsessed with this notion of artificial intelligence. And it seems like a reductive way that we want to simulate the imitation game, the kind of approach that Turing suggested back, can machines think? Which I remind you, he came to a conclusion that that's a meaningless question. And he felt it sort of, analogous to do airplanes fly? The question of what is the essence of an operation, especially when you're trying to apply it to the human mind. So my thing nowadays, you've heard of the hard problem of consciousness and artificial intelligence. I'm more interested in artificial wisdom. Is it possible for wisdom to be produced? Because I think that's the sine qua non of being a human being. I think that's what makes us individuals. I think that's why there aren't, 30 different, there are 30 different types of great primates in the world, but nothing like a human being. And so from my perspective, I'm more interested, kind of in this notion of the hard problem of wisdom. Where is the origin of wisdom? Where does it come from in a human being? Deepak and I spoke with Noam Chomsky and Roger Penrose 2 years ago here in San Diego when Stuart Hameroff organized his conference about the science of consciousness. And I came away depressed from that in a sense, because they can't even agree if electrons or Frank's beloved quarks that he has done so much with, if they're conscious. And to me, a field, in that state, it left me depressed, except when I started to realize that we are the only creatures that we know that have real sense of wisdom. And so that's what I'm more concerned with.
That's great.
What is wisdom?
I was reading Frank's book, and I have to say, first of all, congratulations on the book. It's brilliant. And it raises more questions than ever before. And one of the questions is, of course, can the human mind, the human brain, does it have the capacity to actually even know what fundamental truth is? And so when I was, just now, Leonard mentioned Christoph Koch. And, Christoph Koch, of course, worked with Francis Crick, whom you quote, Dr. Wilczek,
yes,
in the book as the astonishing hypothesis.
Which is that mind emerges from matter, basically.
That mind emerges from matter. Now, one of the other students of Francis Crick was Don Hoffman, with whom I've been having many, many, many conversations. And Don Hoffman was actually charged by Francis Crick to prove the astonishing hypothesis, which he struggled with. He's a cognitive and perceptual scientist. He finally gave up. He said, to believe the astonishing hypothesis is to believe in Aladdin's lamp. You kind of scratch this thing, which is the consistency of Jello, and suddenly it opens up a universe for you. So he finally actually has given up on the astonishing hypothesis, and he's now writing about the case against reality, where he says that even space-time are emergent, they're not real, and that matter is a human construct for modes of knowing and experience of human perceptions. And so when I was reading your book, I actually came across this passage where you talk about your grandchildren. And it's beautiful because you say that your grandchild is actually intellectually constructing the physical world.
Absolutely.
What did you mean by that?
Well, babies are confronted with a big problem when they are born. They are not wired up and they get raw sense impressions of the world, which are very confused and very confusing. The electrical signals that arrive in our brains, or the impulses of light that arrive at our retinas, are very, very far from the three-dimensional world that we try to make out of them. We have to take that information, find patterns, process it, interpret it as objects, learn implicitly geometry, and do all kinds of things, learn the distinction between self and not self, and many, many very difficult things that we still don't know how to implement really in artificial intelligence in order to make a usable world, to be able to interpret those sense impressions as a three-dimensional space with regularities and other people, and some parts that are us and some parts that are not us. This is a very constructive, difficult process. And clearly babies, children, humans in general, even adults, don't understand how they do it or exactly how it works. We have not been able to teach machines how to do it, although we're making progress on that. And it's underdetermined in a way, and I'm sure evolution gives us some help by doing some pre-wiring, but we use all kinds of rules of thumb and experience. If you've ever watched a baby, you know they drop food over and over again, or and do these kinds of frustrating experiments that tire out the adults, but the baby finds them endlessly fascinating because they're learning how the world works. And
a baby's constructing the physical world out of
constructing a model of the physical world.
A model of the physical world. So
and
all we do in science is create models. Are we closer to truth, or are we constructing models?
Well, we have much better models in an objective sense, is that they allow us to accomplish much more and describe a much wider range of phenomena accurately. So we don't rely only on our senses, but on telescopes and microscopes and magnetometers and accelerators and all kinds of tools, and demand a description that's consistent with everything those tools reveal. So it's closer to truth. But as you've alluded to, it's an endless process, I think, because we've done very well on the analysis side, I think, in culminating in the late 20th century with what's called the standard model, or I like to call the core theory, which seems to be a very complete theory of matter for practical purposes, with a very wide definition of what practical means. But the process of going from there to describing more complicated objects, even more complicated molecules that we want to use for drugs, let alone human beings or brains, is an ongoing process. And
so the question then is
that's I think is an open-ended process.
Oh yes, is then matter constructing models of matter?
Yes.
Matter is constructing models of matter.
Yep. Yes.
Can we ever create something completely ab initio, Frank or Len, in your opinion? Can we physicists create something that has never existed before? And it's the old question: is math discovered or invented? I mean, do we actually invent, rather than a model, actually physically creating something ab initio?
Well, it depends what your standards are. But let me give you an example that is dear to my heart, that really bore fruit in the recent past. Almost 40 years ago now, I was thinking about fundamental principles of quantum mechanics and how they might be generalized. And for many years, since the discovery of quantum mechanics, so for about 50 years, so since modern quantum mechanics, people thought that all the possibilities for how particles could behave were limited to two, something called fermions and something called bosons. But in the early 80s, I realized there's a wide variety of other possibilities called anyons that would be possible for emergent particles within matter. And in 1984, we made a convincing theory, I think, of how they could emerge in certain states of matter. But it's taken 40 years. And then finally last spring, after many improvements in materials and techniques, and people finally found it, and that without the original concepts, there's no way you could blunder your way into that. And it's fundamentally new, I think, by most standards of what fundamental means, what fundamentally new means. And it came from, it was thought that became embodied in reality.
I have a more prosaic example, or maybe a more poetic example. I created two children. And they're unique, they're new, they never existed before.
But not ab initio. I guess there's the old joke, scientist says to God, I can do anything you can do. God says, oh yeah, can you make a man out of dirt? The scientist says, sure, just get me some dirt. God says, no, get your own dirt. The joke being that, those are materials there beforehand. Of course.
Something out of the vacuum. Is that what you're asking me?
Well, I just mean, creating, is it possible, that matter is, so Deepak asked Frank, do we create the universe? Does a baby create the universe? And Frank answered properly, no, the baby is constructing a model of the universe, but he's not actually constructing a universe. There are people who say we can make a big bang or a black hole in a laboratory. In that sense, do you guys believe that there's evidence for such things?
Well, what kind of big bang in a laboratory? I mean, I think if you made you're creating a new universe in a laboratory. Is that what they mean?
Some claim this. Some claim, you could create a black hole that would swallow up CERN. And
but if you make a black hole that swallows the Earth or CERN or that, why is that something from nothing? I don't.
Well, I think asking for something from nothing is asking a lot, and maybe actually, although it's a grammatical sentence, may not be something that actually makes sense when you analyze the meaning of the words. However, I think a more fruitful question is whether you can get out more than you put in sense of you start with ingredients that don't have a lot of structure or complexity and kind of can't do much, and you end up with an iPhone. And yes, you can definitely do that. We do it. Right?
I guess, I mean, I'm thinking of the inverse. I think we'd all agree you can destroy things. You can destroy matter, right? I mean, you can annihilate it. You can't destroy energy, but you can destroy matter. And in the sense that Frank, asymptotic freedom. I mean, you could explain that. You're basically shielding. Our nature is invisible at some level to our gaze, but I think the inverse of destruction, and that's what I worry about with the vast tools. Carl Sagan said, whether or not we have the wisdom to handle the technology that our knowledge has produced. That is the key question.
That's a big question indeed. And it's not a settled question.
Well, when you say, Brian, can you create a knowledge out of nothing? Is that, do you mean, what do you mean by that? I mean, you always have something that you start with. Even, I have what I, as a baby, developed as my understanding of the world. I have the math that I learned. I may have I may create a new theory of physics or asymptotic freedom, as Frank did, but starting from something, right? What does it mean to start from nothing? That the moment a baby is born, before any central input even before the baby was born, because there's central input in the womb. When the baby is like 8 molecules or has never experienced any part of the world, can it create, I mean, what, can it create something?
Well, first of all, I think we have to give credit to our wives for doing the hard work and creating the baby. Okay. I was present for a few minutes, I believe, at a certain moment. But yes, something that is truly never, it's this old question: is math invented or discovered? And there's difference between, as I said.
Well, that's a different question, though, because invented versus discovered is a question of whether you feel that the universe has some inherent principles that you're discovering, or whether math is a tool that the human brain is inventing. But what you asked before was, can you get something from nothing? So does that mean if I never, before math was there, somebody, Babylonian, I don't know, invented what we might call the first math, Sumerian, but that's not even coming from nothing, because that person had experience of the world and knowledge of the world and had some basis of which to make that jump. So I'm not sure if it, as Frank said, it's a well-defined question to say.
Well, yeah, I guess I'm riffing off what Deepak said. Can you create, is a model of the world the same as creating the world? Or I do believe that it's possible for us to destroy the world. Right? I mean, we can destroy things, that said. So is it a ratchet? Is it a one-way unidirectional process, or does it have symmetry in time? And Frank's, is it a time crystal in some sense?
Okay.
Let me tell you what we can do.
Okay. After that, let me interject.
Oh, go ahead.
Go ahead.
Oh, well, we can produce things that, in a sense, you could consider worlds if your standards are low enough. I mean, in materials, we can create homes for particles and homes for behaviors that are very different from what we find in the world as we know it. So the things with emergent properties that are very different, like anyons, but also computers in general, or smart materials that do things that are not natural, in the sense you don't find in the natural world, and we can design them, and in that sense we're making worlds. And I think as time goes on, the things we can make are more and more impressive. And I don't think it's impossible. I think it's very possible and maybe inevitable that we can make worlds that house intelligences, some people would say we've already done that with computers that beat us at chess and so, but have a more general kind of intelligence. And this would be embodied within some form of electronics, or maybe a quantum computer, in any case, a physical object that's quite different from anything you find in the natural world. And it's not making something from nothing, but it's making, I don't know, in some sense, more from less, or taking concepts and using them to coax matter to do things that we didn't know it could do. And there's a famous, I think the third law of Arthur C. Clarke is that any sufficiently advanced technology is indistinguishable from magic. And I think that's certainly true. If you took someone even from 100 years ago and brought them to today and showed them around, they'd think it was magic, or certainly they'd see that things that they couldn't begin to understand. And
wow, Instagram. I need this on the farm.
And I would be very surprised if 100 years from now, that's still the case, that we could, if we went forward, we would see things that that our minds would be properly boggled, right?
My mind is already boggled. We've been at it now for 50 minutes, and I had guessed we would be speaking for approximately an hour. But before we go to the next question that I have for all of you, let's look at all the books, because that's the purpose. Inform 15 million people out there that these are very important discussions. So Frank, can we look at your book, Fundamentals, the 10?
Here, I happen to have a copy here.
And we will be linking the book. Leonard, your book, what inspired you to write this book? And tell us a few words about your relationship with Stephen.
Well, Stephen contacted me about 2003, and he had read my first couple books and asked if he was looking for someone to write with and someone who understood physics and whose writing he liked. And I was certainly blessed and honored that he asked me. And through our work, first what we did was we rewrote A Brief History of Time to make it simpler and clearer, really. That became A Briefer History of Time, so it was like a new edition. And then he used to visit Caltech for about a month every year, and I was on the faculty there. And so when he came by the next time after that book was published, I gave him a proposal, and I said, why don't we write a book about your new work? Because all his other books were always about his work that he did in the 70s and 80s. And I thought he was doing fascinating things in the 2000s. And that took about 5 years. And so we worked together closely. That became the book, The Grand Design, and got to be friends. And I have to say it was one of the most inspiring or moving, life-changing things that ever happened to me to have that association with him, because he was such a special individual, partly obviously because of his grit and his iron will to overcome his disability, where he had to work so hard just to get words out, and couldn't move or take care of himself. And yet he had a tremendous outlook and sense of humor, but also because as a human, as a person, he had an amazing quality, which is, I think, very important to satisfaction and happiness in life and to thriving in life. And that was a sense of purpose. I think in his younger years in undergraduate, he was floating, and he was kind of a goof off, and he was a brilliant guy, but didn't have any particular thing he wanted to do. And when he got sick, he realized that, or he decided that there were some questions that he wanted to answer about the universe. And that's, how did the universe begin? And why are the laws of nature what they are? And he decided then that he would dedicate what he thought was his last couple of years to pursuing that. And that became decades and decades of that. And I think that really drove him, and that gave him his joy of living, and his, looking forward to being up each day and to attacking these problems, and to working with other people and how they were looking at it. And that was an inspiration to me, because I feel that I found that as well in science, and as he did, in popularizing science. And so he really showed me how, the Stoic philosophy, ancient Stoic philosophy, that and it's not far from your philosophy, Deepak, that your happiness, your satisfaction, your joy or in life comes from within. That you should, that it's good if it's not material things that drive you, or even other people. It's good to have good relations with other people, but really what you are comes from within yourself. And when you have that, then other things that happen to you don't disturb you where they might disturb you otherwise. And I've certainly learned that from you as well, Deepak. You are, about the most calm and peaceful person that I've met. And we've gone through, different periods of things happening, and then you're always just a rock, and you're always smiling, meditating. So that, I have to say, that's pretty amazing too. And so I was lucky enough to have both of you guys in my life, and to become enriched by it.
So what I have to say is that because of you, I had the good fortune to meet Stephen Hawking in New York when he was flown over for his 70th birthday. We watched that ballet called Icarus. It's about this kid who skirts a black hole and gets lost in interstellar space and ends up in a different galaxy. And when he ends up in that galaxy, they say, oh, what spaceship is that? That model went out of fashion about a few billion years ago. So, that was an amazing play. And I'm grateful to you that I met Stephen because of you. Brian has been an inspiration to me. because he questions my habitual certainties. And I think this conversation that we've just had, we could go on forever, and possibly we should. But before we conclude, one of the most interesting parts of Frank's book was his take on complementarity.
Yes.
And I found that very refreshing because I have worked with Menas Kapatos, who also trained at MIT a long time ago. Leonard knows him. And Menas has three principles when he talks about laws, the laws of nature. One is universality. Whatever is here is everywhere. The second is complementarity. But the third you might not like is creative interactivity. And the reason I bring that up is you talk in your book about mass, spin, and charge as the most fundamental properties of matter.
Yes.
Yes? Yes?
Yes.
Okay. And then you also say, and I'm going to read from your book. I hope I can find it. You say, modern fundamental ingredients of matter, mass, spin, charge, have no intrinsic size or shape. They are structured as points where mass, spin, and charge reside. So are they material entities?
Well, by definition, that's what matter is. And as we've discussed now in different forms several times, it's a big challenge to climb back up. So we do analysis to understand the most basic ingredients of matter. And they turn out to be these very strange things, very unfamiliar things. The mass, spin, and charge located at points, or you can, in the spirit of complementarity, you can also look at it in other ways as quantum fields. And then there's the great task of going from those concepts to explain how the more visible aspects of the world arise. And this is the process of analysis and synthesis. And it's a wonderful process that's been fantastically successful.
So, Dr. Wilczek, for a common person like me, I'm not a physicist, I don't understand the math, but for a common person, matter is physical. It's something that I can touch, I can grasp.
Yes.
Mass, energy, and charge don't seem to be physical entities, but they give rise to physical structures that we look at, including our own bodies. Would you be sympathetic, just sympathetic to the idea that mass, charge, and spin are actually principles and processes that govern the interactivity of certain very fundamental laws that ultimately give rise to the experience of what we call matter?
Yes. Well, I think that's an accurate description of how they actually work.
Okay, well, then in that case,
Your PhD has been granted. Now you have an MIT PhD.
Okay, well, in that case, I'm going to conclude our talk.
So the point of these concepts is that they go together with rules for how you use them, very precise rules for how you use them. And those rules are things that govern how more tangible aspects of matter emerge. So that's absolutely.
Got it. I totally understood. So I'm going to just ask you a few questions and just respond yes or no. Because, and feel free, Leonard and Brian, to interject. Since we talk about complementarity, are space and time complementarities?
No, space-time is a unity of the two. And I don't know of any useful way in which you can regard space and time as complementary. complementarity in general is the idea that you can describe the same thing in different ways. So space and time are
not that.
In sense, they're not complementary. They're in a way they're almost the same thing, but in other ways they're different. So yeah, I mean, so the answer to your question of yes or no is a complementary answer is yes and no, both depending on how you exactly pose it.
That's very quantum. That's very quantum. Yes and no. So in my mind, space-time, wave particle, mass energy, body-mind, biological organism, world appearance, conscious, subconscious, science, philosophy, and you mentioned humility and philosophy.
Humility and self-respect, I think. For me, that's the most important.
Are all complementarities in my mind, because they're different ways of looking at the same entity.
I agree with some of those, and I disagree with others.
But in general, I think the more ways you can look at something and use those viewpoints to answer important questions about that something, the better off you are. And that's
are free will and determinism complementarities?
Absolutely, they are complementary, because we experience free will. And free will is a necessary ingredient of the law and the moral codes. But on the other hand, determinism is built into the equations of how we describe matter very profoundly. And if you ask other kinds of questions about us, since we're made out of matter, you will get determinate answers.
Well, I don't agree. I think that free will and determinism are in opposition.
No.
So they're not describing the same thing. I think that if you believe in determinism, then there is no free will. There's only an illusion of free will.
No, I disagree with that. That's
I believe you do.
That's the result, I think, of a much too narrow conception of what free will means. And if you don't, I mean, if you don't believe in free will, how could you have laws? That how do you make a distinction between sanity and insanity? I mean,
well, those are all, look, the distinction between insanity and insanity are, whatever, artificial.
I mean, according to the law,
guilt and innocence.
It's a crime if you.
Right.
It's a crime.
It's like, the Big Bang made me do it. The Big Bang made me do it.
That's not true. I would argue that if you knew the exact state of the person at a given time, and the laws of physics apply, and as you said yourself, you don't believe that anything outside the law of physics applies to the brain, then you would be able to predict in principle what the brain is going to do.
Yes, but all those are big ifs. Those are big ifs. First of all, quantum mechanics tells you can't.
I don't want to say if. I'm not saying that you have to stipulate that. I'm saying that if for what you say to be true, then this, what we call is of free will, because we don't know how the brain is doing the calculation. So it seems like it's free will. But if physics really governs the physical world 100% with no exceptions, then to know everything that there is physically about the brain would allow me to predict the state of the brain at a later time, which would allow me to predict its actions if I could do the calculations. Now, free will is the word. Wait, let me just finish. Free will I call an effective theory because it's the word we give to it, because we can't do that and we can't do the calculation. So it's the illusion of free will because we're not capable of predicting what the system is going to do in the future.
No,
but in principle, because we're talking principle, in principle, there is no free will. It's only in practice that we seem to have free will.
Okay, Leonard, what Frank is saying is quantum uncertainty actually says that there are problems.
No. That's dangerous ground. No. What I'm saying is okay. So I'm saying that free will is a concept that stands on its own, that is extremely useful and absolutely necessary.
I agree.
If you're dealing with your own experience or with the law or with many moral concepts, So it's a concept we need. Saying it's an illusion is, I think, very wrong, because it's not an illusion. It's a thing that really applies in the world in very concrete circumstances. And we can discuss why it's a useful concept on the basis of, even though the underlying description at some level is using determinate equations. First of all, so if you had a complete description of the human being, you could predict their behavior, but you can't have a complete description.
I totally agree.
The wave, we can't get the wave. It's not just a matter of practicality. We can't. The wave function has much too much structure. If you measure it, you lose that structure.
Interaction.
And there are severe practical problems in calculating the behavior of any complex object. Even in classical mechanics, there's sensitivity to initial conditions, sometimes called chaos. And that's a practical problem that's so severe that it's a problem of principle, because it would take you so much time and so many resources to calculate how something behaves that you would use up the entire universe and all its time and all its
and you
matter.
need to know the
You can't actually do it.
Right. You also need to know the wave function of the universe.
So we need, in practice, we need concepts. Then this is the essence of complementarity. You need alternative concepts in order to describe the world.
Yeah.
And it
Frank,
won't do to.
I'm not saying that they're not useful and you don't need them to describe the world. Just like your brain calculates, as you said earlier, an illusion, it creates a reality for you from the data that comes to your eye. So I agree with all that. But what's dangerous about talking about free will the way you're doing it is the people who don't understand physics, who think that the randomness of the wave function and the different ways that a wave function can.
Oh, he didn't say that. He said the interactions with the.
Please let me just finish. Please let me just finish.
All right,
And different ways that the wave function can be measured, those different outcomes. When you attach them to free will, it seems like our decisions that might be based on good and evil somehow are not are being determined by the physics. And what I'm saying is all that is determined by the equations. We can't predict what the outcome of the equations are. And yes, when you measure something in quantum mechanically, you can get different answers with different probabilities, but those are totally independent and have nothing to do with what we think of as the decisions of humans, such as good and evil and things like that. So we have to be really careful when you use that concept.
Yes. Well,
misunderstand.
In any application of complementarity, and this is one, you have to treat the different sides on their and within their own context and within their own domain, and applying the idea that human beings are determinate and there's nothing you can do because it's the way you were born, it's your wave function, would make a mess of the law and morality. And on the other hand, saying that mind can affect matter and you can, by wishing, make it so, and do faith healing, I think those also are very wrong. So when you apply complementarity, you have to be true to the idea that different concepts are important for answering different kinds of questions, and neither one exhausts the full reality.
Brian, any last comments from you before I have the last word?
Yeah, I just say that I have to believe in free will because I have no other choice.
Right.
Thank you, guys. That was really fun.
No, don't go. I want to have the last word, and then I want everyone to maybe comment, maybe, if you want to. But I do want to have the last word right now because, first of all, I want to say that this was a very illuminating conversation for me. I continue to learn from all of you. Dr. Wilczek quoted Wittgenstein in his book. See, Frank, I read your book. I read every sentence. So, Wittgenstein is a favorite philosopher of mine. And also, I've been a fan of Schrödinger and his interest in the origins of life. And right now we are in a very interesting phase of questioning everything, including Darwinian evolution. Okay, here we are. This is the latest issue of, not the latest, but a new issue of New Scientist, which questions some of the dogmas of random mutations in natural selection. So we're in a very interesting time. But it was Wittgenstein who said in one of his essays, "Our life is a dream. We are asleep. But once in a while, we wake up enough to know that we are dreaming." So I come from a tradition which is the exact opposite of what we've been discussing. What we've been discussing is matter as the ontological primitive of the universe. And that's an assumption. You have to start with an assumption. Anything starts with an assumption. So matter is the ontological primitive of the universe is the way we do science, and it works. No question about it.
That's right. Didn't have to work.
No, it predicts the outcomes of experiments. Let's say that. And it creates technology, which saves our lives and so on. But also the way we've done science, we've created climate change, we've created cyber hacking, we've created extinction of species, we've poisoned the food chain,
nuclear weapons.
And nuclear weapons. And we are basically on a collective suicide mission at the moment. If we don't wake up to climate change and all this, even the pandemic, we say it's a mutation, but it's linked to the dysbiosis of the genetic information of our planet, which is due to, I think, can be connected to climate change as well. So in any case, in your book, you also mention species-specific experiences. A bat only knows the echo of ultrasound. Bees navigate through ultraviolet. An insect with 100 eyes, I don't know what it sees or what it experiences. On and on. I can look at every species and look at it as having a bandwidth of experience. The human bandwidth of experience is less than 1% of the visual spectrum. Acoustic
No, but you're missing an important.
No, we can extend that through instruments. We can
through instruments we can. That's
infrared and radio waves and
we can know what we don't know, and then we can do something about it.
Yes,
right?
Absolutely. But all this begins with the mode of knowing and experience in human consciousness. Science is an activity in human consciousness. Mathematics is an activity in human consciousness. I think of mathematics as unbelievable, amazing imagination in consciousness that somehow corresponds to the physical laws of nature. Then you have Gödel's theorem, which says there are laws that can't be proved. Then you have the cosmological constant, which is way off. But then you have dark energy, dark matter. So we have lots of issues to solve. Now, I come from a tradition which says that the ontological primitive of the universe is not matter, that matter is a human construct for modes of knowing and experience in human consciousness, that even the brain and the body and the physical world are a unified experience that we call mind, brain, body, and universe. But in fact, these are human constructs for modes of knowing and experience only in human consciousness. So when Einstein said the moon would still be there, was when no one was looking at it, I think he meant a human moon, not the moon of a horseshoe crab that comes from the depths of the ocean to the surface, lays eggs on a full moon night, and birds come to feed on it with exact precision of ecosystems, weather patterns, biological phenomena, gravitational waves, the earth spinning on its axis and hurtling through space at thousands of miles an hour. All of this is correlated somewhere. And therefore, what we call the scientific universe is a totally human construct. and a very useful model that takes us closer to truth. But what truth is a great mystery still.
Well, there are many things we don't know, but there are also things, there's a lot we do know. And
yes, but who's the we that seeks to know?
Well, I would say, you want us to comment on this?
Well, I can speak for myself.
Yes.
I want to know.
All of you speak for yourself.
That's,
Why is the experience of a caterpillar less legitimate
No, I'll
than
say,
the experience of a human being through a human nervous system?
Deepak,
well, I would just
I
go
would say-
back to what I've went through at some length before, which is that so far we've never had to make allowances in very, very delicate experiments for what people are thinking.
But
Well,
we still don't know what produces thought. What is
But
thought?
if any such effect could be demonstrated, well, would be fascinating, would win several Nobel Prizes and fame and fortune. And so there's an outstanding challenge. Do it. If you think that mind can affect matter, show me.
Deepak,
Every
In
time
my tradition, and
every time I lift my arm, mind is affecting matter. Every
Well,
time
but
I
oh
pick
no,
up-
but but mind. Yes, mind is affecting matter, but we can trace how that works. I
yeah,
mean,
we
mind
can
is-
trace that.
Mind is working through matter to do affect. I mean,
Right now, we are having a conversation.
yes, right.
And if this conversation was scary, everybody in the world who was watching us, their cortisol level would go up. Their immune system would be compromised.
Yeah.
If this conversation elicited awe and wonder and joy, they would make serotonin and dopamine and all this. So I personally feel that the distinction between mind and matter is an artificial distinction. They are complementarities of a deeper reality.
so you
That could
believe
be.
in panpsychism?
No, panpsychism assumes
That-
the existence of matter. What I'm talking about says matter is the illusion, even mind is the illusion. There's a deeper reality that experiences itself as mind and matter, and these are complementarities of that deeper reality is, and we don't know what that reality is other than mass, charge, and spin.
Deepak, when you say that you raise your hand, I don't agree with the part that says it's your free will that caused your
No,
hand.
I didn't say free will, it's an intention.
But wait,
It's
your
an
intention, your free will, it's not, it's still explainable by physics. But what I agree with, and this is, I think, the deeper part of what you were saying, is that I agree with you completely that in a sense that I don't say that matter, charge, spin is any truth or any fundamental, necessarily fundamental aspect of the universe. It is a construction of these concepts, and the theories that we build from them are constructions of the human mind that is peculiar to the way our mind is constructed. Intelligent aliens who have a different kind of a mind, maybe a horseshoe crab, but much more intelligent, or a bat, could construct their theory of the universe using completely different concepts, I believe, come up with the same usefulness of their equations and their predictions. They would sense, they would perceive things differently, but they could have a completely different viewpoint, just as, in physics, for instance, Feynman's formulation of quantum theory is different from Heisenberg and Schrödinger's formulation. They could have completely different mathematics based on different concepts that we may not be able to comprehend, that are maybe beyond us or just different from the way we.
That's a
I-
thesaurus, right?
But if both descriptions have the same experimental consequences,
Right.
Well,
they're equivalent in a very specific sense. And yes, I think
they could, but they might not have anything that we would call mass, charge, and spin that's easily identifiable in their theory.
well, it's not logically impossible, but all I can say is lots of luck.
Well,
Good.
I think at some point we have to conclude.
I once met a
Some
person.
point.
Sorry.
At some point, we have to conclude,
All right, let's
unless
cut it
we
off.
want to have another conversation. Let me ask all of you, Frank. I've been reading Sean Carroll's book, Something Deeply Hidden. He posits infinite universes, almost, multiverses and infinite
Yes.
universes. Leonard, in his book, Grand Design, mentioned M theory and possibly 10 to the power of 500 universes. Brian, I don't know what your take is. What do you guys think of these models?
I asked Sean that. Oh, sorry. Go ahead, Frank.
Well, I think they're very speculative. They are inspired by physical phenomena, but they don't explain a lot, and their consequences are rather nebulous. So they are not part of the core of our understanding of the universe. Yeah. They're interesting speculations and fun, but to me, they're not the center of interest in physics or our fundamental understanding.
Yeah, I've researched this a lot in terms of trying to find the complementarity between physics and faith. And I found many faith-based statements that assume these to be correct, including based on my conversation with Len last week, that Stephen Hawking sort of went to his grave, as far as I understand, believing in the veracity of M theory, for which there's currently a complete absence of experimental data. And so I find it, interesting that in Frank's book, he talks about this, how this is the interesting aspect of the complementarity of the multitudes within us, and sort of the humility that we also have to have as manifest through, understanding the limits of our knowledge, but also, as I say, checking your biases, because we do have this anthropomorphization, fetishization. And I think I want to particularly be on guard about that. So I am very anti-multiverse. I did ask Sean, I said, what's the probability that God exists? He said less than 1%. I said, what's the probability that the multiverse or the many worlds of Everett exist? And he said 50-50.
By the way, in the Indian philosophical system that I'm talking about, there's no room for God as a person, but there is room for God as pure consciousness that differentiates into different modes of knowing, different knowers, and different modalities known that are species specific. And no one species has a privilege to truth over the others. We have the privilege of creating better models of the truth.
I'd love to debate that from the Judeo-Christian perspective.
And creating technologies that extend our experience of virtual reality.
Yes.
We're already in a virtual reality.
I'm with you.
Now with technology, we're expanding that with all the wonderful insights that you guys are supplying. I'd just like to conclude with a quote from Rumi. He says, if you're not bewildered by now, go back to sleep. So elsewhere, he says, exchange your cleverness for bewilderment. And I think the scientific pursuit is based on mystery, bewilderment, awe. And if we don't have those, our humanity is incomplete. And as long as we keep questioning, every theory of science so far has proved to be untrue. Every theory so far has been found to be incomplete.
Incomplete, yes.
Yeah, but as Isaac Asimov said, Deepak, never forget what Isaac Asimov said. He said, if you think the world is flat, you're wrong. But if you think the world is perfectly spherical, you're also wrong, but you're less wrong than if you think it's flat.
Yeah, but you see, the magical illusion of the flat Earth makes it possible for me to walk on the Earth. If I knew it's spinning at dizzying speeds and hurtling through space at thousands of miles an hour, and I knew that my body is proportionately as void as intergalactic space, I wouldn't have a life.
No, not after you get your PhD from MIT with Frank. After you get that, you'll have no more worries, no neuroses.
You would. I mean, you can perfectly well get around it. And I think these scientific insights about the world spinning around and moving add to our understanding of reality. They don't replace or void our working models of how to get around in the world that we construct as babies. They add to it. And
add to it, but they also convince
my
you.
mission in fundamentals is to expand people's minds, not
Absolutely,
to feed
and
anything into them.
I'm
Right.
grateful to you for that.
Right.
But I also
Right.
believe that what we call physical matter and the world of perceptions is a magical lie, period. It's a very workable and interesting magical lie. But
We need a
again,
part 2
Magic.
because I'm late for dinner.
I'm going to bring a bottle of scotch.
okay,
Got one.
before we end, the gentleman, everyone listening to us, Dr. Wilczek, he's a very humble person. He could have named the anion the Wilczek particle, but he didn't. Okay. So I'm grateful to you, sir, for your humility. Leonard, for being so open to these conversations, and Brian, for bringing us together, and all these wonderful meetings we've had with Sir Roger Penrose, Stuart Hameroff, and all these great people who are bringing us closer to truth. If